Good morning, here we are. It's the Physics 2A video lecture. Physics 2A video lecture 1. My name is Carl Rundy. You can call me Professor. And we're going to just begin by going over the syllabus. The lecture will be short. I'm just going to give you a heads up and instructions on everything that we're going to be doing. Primarily in this first week and a half, we'll be meeting on January 31st. Looking forward to that. Okay, so Physics 2A. And looking at our syllabus together, I sent it to you in an email. And taking it down the top there, we get to the lab topic. You must pass the lab in order to pass the course, and the lab policy will be furnished by the lab instructor. So yeah, that's all we have to say about that for now. Next, the text is College Physics by Surway. It's the 11th edition that we're using here, and we're going to work through the first 14 chapters. Okay. The book I have in my hand has an entire 30 chapters, and if you're taking Physics 2B, after you take Physics 2A, then you could use the entire book. We'll be going through the first half. Chapters 1 to 14, mechanics, thermodynamics, vibrations, and waves. Then I have a thing about homework problems from the text, etc. I'll get back to that, namely for this week's homework problems. Then I have exams already scheduled, including the final exam. And then it gives the weighting of all these scores, the homework 10%, the lab 15. So the lab instructor will send me your lab score, and then I'll fold it into the main grade. Midterm exams and the final exam. Final exam's worth a lot, so there's always hope. Okay, and then I have the letter grade scale. When we're together in person, we can talk about these things some more. Now, on the other side of the page, the GE assessment requirement, which you will choose, for that you'll choose a lab report from the lab. So again, we can talk about that when we're together. What I want to now discuss is the homework assignment for this week. So there will be, so we'll go ahead and get it started this way. Homework. And it's going to be due January 28th by, not at, it can be earlier, January 28th by 6:00 p.m. So that'll be one assignment until we meet. And what that assignment will be is to send me pictures of your excellent handwritten notes, okay? So send pictures of handwritten notes. Okay, and should I say a little more about that? Yeah, this is going to be the first, the beginning of your entire notes for the semester. You want to write everything down that I write down and leave a lot of space. You can fill in, you can stop the video, fill in with some words. You can leave space to put in extra calculations, extra steps. Okay, so you want some really nice handwritten notes. And when I say you send pictures of them, you can take them with your camera. Everyone seems to have a camera nowadays. And you send them to my email, KRUNDE at csufresno.edu. The first thing I have to note is you want to open a new message, not responding to the email I send out to you, because it may get lost in the whole queue. So you open up a new message, And the second thing is the subject will be your name, and then Physics 2A homework. Physics 2A homework, how about that? So that'll come to me on the 28th, and here I'll use another color. It'll come to me on the 28th, and I'll look them all over and check off that you did it. And then the 31st, when we meet again, you'll also have written homework from the homework problems, but I don't want you to send those to me, but you'll bring them to class and we'll talk about them, and then I'll collect that kind of thing. Good. So there will be handwritten notes of all lectures. This one I'm going to end with a interesting brief little geometry problem just to get us started. But yeah, you'll send handwritten notes of all lectures. So that's going to be lectures 1, 2, 3, and 4. And should be labeled as such. It was 1, 2, 3, and 4. That'll be quite a few pages. You should be taking a lot of notes, and then you could lay them out on a table, take pictures of them, and I'll recognize what's on them, no problem. Okay. So in addition to this, you'll see the videos after this one, so 2, 3, and 4, will also have problems to be done, or recommended problems, out of the back of this book, or out of the back of each chapter. Video lectures, so the problems from the text. So you want to do as many of those as you can, but like I said, when we meet again, or when we meet in person, then we'll really deal with that stuff. But when you do the problems from the text, you're at the back of the chapter. It'll be 1 and 2, and I'll show you what we have here. In fact, they don't call it chapter 1, they call it topic 1. Okay, I call it chapter 1. And if you get to the back of chapter 1 here, there are conceptual questions, but you keep going till you get the problems. That actually says problems, and when I assign something out of the book, it'll always be taken from those problems. Okay. A little bit of mathematical review and stuff. So problems from the text. Turn in face to face. I'll just say that. If you have them, when we're face to face, if you have some or all of them by the time we meet on the 31st, that's fine, but we'll have a little grace period there because I'm going to want to go over things with you. Okay, good. So that's the main thing. This lecture is just to get us started, and I think this is pretty clear. If you have any questions, you can always email me a separate message as well. So what I want to end with is an interesting little geometry problem that's going to have a lot of significance, and we'll work with that problem in the second video lecture. So let's, I'll erase this and put this problem up for us. And this problem is actually typical in a way of the way we work. So let's just go ahead and draw a little geometrical scenario here. We've got a circle, and from the center, we'll take a ray out here. From the center, we'll also take one out here. Okay, so you want to construct this. Yeah, when you draw pictures in your notes, by the way, make them generous and large so that everything's clear. And we'll take a ray out this way, and these two are parallel. Okay. So suppose we have an angle theta right here. And this arc length I'm going to label S. So we have the angle theta, we have the arc length S, and of course, that's a radius. We want to find an algebraic relation that says that we can express R in terms of S and theta. So here's your problem. You want to construct or find a little algebraic relation, R in terms of S and theta. And in the next lecture, we'll discuss this more and see that it's related to astronomy and geography. So it's a beautiful little relation there that you guys can look up. Okay, I think I've covered what I wanted to talk about. Lectures 2, 3, and 4 that I'll post will have quite a bit of material for you guys to work on. Hope you enjoy it, and we'll see you next time.